To determine the total cross-sectional area of a group of conductors, you need to follow a few steps. Firstly, identify the type and size of each conductor. In this case, we have 4 number 12 THW conductors, 3 number 10 THHN conductors, and 5 number 8 THHW conductors. Secondly, find the cross-sectional area of each individual conductor type. For a number 12 THW conductor, the cross-sectional area is 0.201 square inches. For a number 10 THHN conductor, the cross-sectional area is 0.159 square inches. For a number 8 THHW conductor, the cross-sectional area is 0.103 square inches. Thirdly, multiply the cross-sectional area of each conductor type by the number of conductors of that type. So, for the 4 number 12 THW conductors, multiply 0.201 square inches by 4, which equals 0.804 square inches. For the 3 number 10 THHN conductors, multiply 0.159 square inches by 3, which equals 0.477 square inches. For the 5 number 8 THHW conductors, multiply 0.103 square inches by 5, which equals 0.515 square inches. Finally, sum the cross-sectional areas of all the conductors. Add 0.804 square inches, 0.477 square inches, and 0.515 square inches. The total cross-sectional area is 0.1796 square inches. Let's recalculate those multiplications and sums to ensure accuracy. 4 number 12 THW conductors with an area of 0.201 square inches each equals 0.804 square inches. 3 number 10 THHN conductors at 0.159 square inches each equals 0.477 square inches. And 5 number 8 THHW conductors at 0.103 square inches each equals 0.515 square inches. Now, adding those together, 0.804 plus 0.477 plus 0.515 equals 0.1796. So, it seems there was an error in the original calculation provided. The cross-sectional area is 0.1796 square inches. If this value is not one of the multiple choice options, double-check the cross-sectional area values for each conductor size. These values can typically be found in NEC Chapter 9, Table 5 or similar reference tables. Also, we perform the calculations to verify your arithmetic. It is crucial to use the correct cross-sectional area for each conductor type, as slight variations can occur depending on the insulation type. To reiterate, the step-by-step process involves firstly identifying the conductors and their types, secondly finding individual conductor cross-sectional areas, thirdly multiplying the individual areas by the count of each conductor type, and lastly summing the areas. It is a simple process, but accuracy in looking up the correct values and double-checking the math is important. Using a calculator is always helpful to avoid arithmetic errors. Always consult the latest edition of the National Electrical Code, or NEC, for the most accurate and up-to-date values for conductor properties, including cross-sectional areas. Be aware that different tables within the NEC may list slightly different values, depending on the specific application and insulation type. Therefore, ensure you are using the correct table for the type of calculation you are performing. Keep in mind that when performing electrical calculations, accuracy is critical for safety and compliance with regulations. Always double-check your work and consult with a qualified electrician or engineer if you have any doubts. Using incorrect values or performing calculations improperly can lead to dangerous situations. Remember, firstly, identify the conductor types and sizes. Secondly, find individual cross-sectional areas from appropriate tables such as in the NEC. Thirdly, multiply the area of each by the number of conductors of that type. And fourthly, sum the areas of all conductors. If the final calculated value does not match any of the multiple choice answers, then re-verify all steps, especially the values obtained from the NEC tables, and recalculate everything carefully.